Welcome to The Explainer. Today, we're breaking down what's got to be one of the most exciting and yet challenging exams out there for engineers, the GATE paper for data science and artificial intelligence.
And hey, make no mistake, this isn't just another test you have to cram for. Think of it more like a gateway, a real launch pad into what are probably the most dynamic, future-shaping fields in tech right now. All right, so let's dive right in. We're going to start with the section that every single candidate has to face no matter what, general aptitude.
So, first up, they're going to test your command of English with questions on things like analogies and vocabulary. You'll see stuff like this, where you've really got to understand the subtle relationship between words. And this isn't just random trivia. It's a super important skill for when you need to read complex technical docs or, just explain your ideas clearly. Okay, so then it flips over to your quant skills. You'll have to dust off your geometry and algebra and apply it usually under some serious time pressure. The tricky part here? It's often not about finding one specific number. It's about figuring out which statement is always true, no matter what L and W are. It's a logic puzzle disguised as a math problem.
And then there's this kind of thing, which is a perfect example of why you need sharp spatial and logical reasoning. You've got these visual puzzles, like this dice problem from the 2024 exam. You literally have to fold this paper in your head and figure out which one of these nets could possibly make that die. It's a real brain bender. All right, so that's the aptitude part. Now, let's get to the real heart of the exam and see how all this stuff builds into the core technical subjects. Okay, now we're getting into the core stuff. A massive part of the syllabus is dedicated to probability and statistics. And you might ask why? Well, it's because this is literally the language of data. It's how we deal with uncertainty, how we find signal in the noise. Honestly, mastering this, it's completely non-negotiable for this field.
And you're going to have to apply these concepts to solve really practical problems. Something like this, calculating the odds of a specific outcome. But here's the key. It's not just about memorizing formulas. It's about understanding when to use them and how to apply them correctly.
Next up, we've got linear algebra. If probability is the language of data, then think of linear algebra as its grammar. It gives us the structure, the rules, for handling huge data sets and building machine learning models.
So, for this part, you'll be expected to really dig into matrices and understand their deeper properties, things like eigenvalues. And what are those? Well, they basically tell you the core scaling behavior of a matrix. The big takeaway here is that the exam is more interested in your conceptual grasp. It's not just about being a human calculator, it's about knowing what the numbers actually mean. And of course, none of this theory matters if you can't actually build anything with it. That's where a strong foundation in programming, data structures, and algorithms comes in. This is your practical toolkit for building solutions that are efficient and can handle real-world scale.
The exam will test you directly on this stuff. A question might look like a simple matching game, connecting concepts, but it's actually a really smart way to check if you get the fundamentals, like knowing when you'd use a queue versus when you'd use a stack. It's all about picking the right tool for the job.
Okay, so we've got probability, linear algebra, algorithms. The crucial part, the final boss, if you will, is seeing how all these foundational pieces snap together in the most advanced section, machine learning. And this is where you'll face some really complex problems, like analyzing a multi-layered system, like this neural network. Yeah, I know, it looks pretty intimidating at first glance. But if you take a breath and look closer, you'll see it's just built from all the things we've been talking about, matrices, functions, and a clear logical flow. See, the question they're asking isn't just, hey, do you know what a neural network is? It's more like, can you actually trace the data's journey through this thing? You have to deeply understand how that input gets transformed, step by step, layer by layer, as all the weights and activation functions do their thing. So, to crack a problem like this, you've got to pull everything together. You're integrating multiple concepts all at once. You're tracing that data path, applying the activation function at every single neuron. It's the perfect mashup of linear algebra and computational logic. Okay, so after seeing all that, you're probably wondering, what's the best way to actually prepare for a challenge like this? Well, here's a simple 3-step roadmap. First, solidify your math foundations. You've got to master probability, linear algebra, and calculus. That is the bedrock. Step 2, get fluent in core computer science, algorithms, data structures, databases. And finally, step 3 is where you connect it all. You take that foundation and apply it to tackle machine learning and AI models. And remember, each step builds directly on the one before it. Ultimately, just mastering this material is only the first step. Passing this exam, that's not the finish line, it's the starting gun. And that leaves us with one last really important question for you to think about as you start your journey. How are you going to use all this knowledge to help build the future?